Let's talk temperatures. There is a linear relationship between degrees Fahrenheit and degrees Celsius. For water, the freezing point is 32 degrees Fahrenheit, 0 degrees Celsius, and the boiling point is 212 Fahrenheit and 100 degrees Celsius. Let's write the freezing point as an ordered pair, Celsius first, then Fahrenheit. So here's freezing. We want Celsius to come first, then Fahrenheit. In boiling, Celsius first, then Fahrenheit. Okay. And it really does, I mean, in this case, you just want to make sure you're consistent. So if you're putting Celsius first, it needs to be first in both of them. All right, so we have two ordered pairs. Let's use those values to find the slope. Okay, well, I'm going to come back because I have more room on this page. So remember that slope is the change in y over the change in x. So I take y2, here's y2, here's y1, minus y1, here's x2, here's x1. So then I take x2 minus x1. And I get 180 over 100, which reduces to 9/5. If you hate fractions, it does terminate, so you could write that as 1.8. So our slope is 9/5 or 1.8. Now let's write the model. Well, recall that the b is our starting point, and that's when x has a value of 0. So our y-intercept is b. So my model is y equals 9/5 x plus 32. And this equation can be used to do any of these. So if we graph this, we have 0, 32, and we have at 100, we're up to 212. So here would be our linear relationship. If I make the dot big enough, it works. It's hard to do on here. But that would work, right? So if I would pick, 50, here's the temperature for 50. It's a nice linear relationship. So how would we create a linear model that would convert Fahrenheit to degrees Celsius? So this is Celsius to Fahrenheit, and so if we wanted to flip it, well, we would just flip our ordered pairs. We would put Fahrenheit first and then Celsius, and so our ordered pairs would be 32, 0 and 212, 100. The only issue is now we don't have a y-intercept because we don't have an x value of 0. So you'd have to work a little harder to find your y-intercept. All right, so given what it is, we just showed how they found this formula, and if we would do it the other way, we could get our other formula. So depending on what you're given, if you're given Celsius, we use this formula because then we can find Fahrenheit. If you're given Fahrenheit, you use this formula because then you can find Celsius. So whatever you're given, that's what you want to be in the beef of the equation. And so you really can use either one. You'll get the same answer. You just have to do maybe a couple more steps. Just remember, you always want to follow the order of operations. So like in this one, you have to do inside the parentheses first. This one, you have to multiply first before you can add. So order of operations are important. Let's do a couple. You get sick while in Montreal and you go to a clinic. The nurse says your temperature is 38 degrees Celsius. Should you be concerned? Well, I don't know about you, but I don't know Celsius temperature. So I want to turn this into Fahrenheit. So I'm going to use the formula Fahrenheit equals 9/5 Celsius plus 32, because whatever I want to find should be by itself. So this 38 gets plugged in for C. So I have 9 divided by 5 times 38 plus 32. Now this is all one step. 9 divided by 5 times 38. Just plug it in all at one time, and you should get 68.4. Then we add the 32, and so that temperature is 100.4 degrees Fahrenheit. Should you be concerned? I don't know. If it's me, I'm not concerned at 100 degrees. If you've got a 6-month-old baby, then maybe you should be concerned. But for me, nah, let's go hang out in Montreal. Convert a comfortable room temperature of 72 degrees Celsius, Fahrenheit, 2 degrees Celsius, and round to the nearest hundredth. Okay, so now we're trying to find Celsius. So C equals 5/9 times F minus 32. So I'm going to take this degrees Fahrenheit and I plug it in for F. So I have 5/9 times 72 minus 32. First order of business, inside parentheses. So I subtract. 72 minus 32 is 40. Then I can do the 5 divided by 9 times 40 all in one step, and rounded to the nearest hundredth, I get 22.22 degrees Celsius. That sounds a lot colder than 72 degrees Fahrenheit. You need to refrigerate your potato salad at 39 degrees Fahrenheit. What do you need to set this at Celsius? So again, we're using Celsius equals 5/9 F minus 32. We're going to take that Fahrenheit and plug it in for F. So 5/9, 39 minus 32. inside parentheses gives me 5/9 times 7. 5 divided by 9 times 7 yields, again I'm going to the nearest hundredth, 3.89 degrees Fahrenheit. And that's the temperature conversions.